Okay. All right. Still screen sharing. You can still see that. Okay, so we're going to continue now by talking about the relationship between programming and maths. Okay, because obviously there's some kind of relationship to it, and I promise that this is not going to be terribly painful, but there is some basic level of maths that you need to be able to do this course, and we will touch on that. Okay, so people will often think when they start programming that maths is going to just be like this, that a university course is just going to be like this. It's just going to be an absolute sea of equations that you're wading through, okay? So for those of you who are frightened of mathematics, this would be your worst nightmare, and we're not doing any of this, okay? So you can very much relax. Okay, so let me just show you a very quick mathematical proof, incidentally. Okay, have a look at this one, right? There's something weird about it, right? Because if you look through to the bottom line, you will see that the bottom line says 2 equals 1, right? So if you've got a year 9 who's just starting to learn how factorizing works, by all means, show them this because it will drive them a little bit crazy. And if they're the sort of year 9 that would like to drive their maths teacher crazy, get them to take it to class. Okay, there's a very subtle error in this proof. Okay, and this isn't actually the last line that I want to show you. Because if 2 equals 1, then you can take 1 off each side and 1 equals 0. And that is all very confusing. Can anyone actually see where the subtle flaw is in this math? Yeah, it kind of makes sense. You square both sides, you subtract b squared off both sides, you then do a little factorize, you then divide both sides by a minus b, and then you just end up with that. All seems very reasonable. Okay, so where's the flaw? There must be something in there that's wrong for us to get to that, but it's actually quite difficult to see. Can anyone see it? Okay, well, there is a hole in it, and the hole is on this line here. You can't actually divide both sides by a minus b because a equals b, and a minus b would be 0. So you'd be dividing by 0. So you can't actually do it. Okay? It's very subtle. And part of the reason I wanted to show you this is because if you try and divide by 0 within Google Colab, you'll get an error as well. Like a microprocessor will not allow you to divide by 0. So you'll see that error as you go. It's a very common thing to get. Okay, so enough of math. If we shift into programming world, this is a legitimate statement, x equals x plus 1. Okay, in maths, it's not because you can subtract x off both sides and you get 0 equals 1. Okay, so this is the difference between math and programming. Okay, this is mathematical nonsense, right? Those of you who have done the AI lab will know that this is a legitimate piece of code. This line expresses 5 tokens. 5 tokens start and end based on spaces around it. And one of them is a literal, the 1. The programmer has put in that. One of them is an operator, a plus sign. One of them is an equal sign, which binds the left-hand side to the right-hand side, right? So far, so good. Mathematically, it doesn't make sense, but from a programmer's world, it makes complete sense. So Python will run this line, whereas a mathematician would look at this line and go, that doesn't make any sense at all. The key take-home points is this. Programming and maths is different. The equal means something different in maths. This is a different thing in programming. And the plus means something different as well. Yeah. You kind of all have the sense that you can have plus with strings. Okay, so if you go x equals, I'm just typing in the chat, 1 plus 2, and then you go print x, you get 12. Okay, because the plus does something different with strings than it does with numbers. Okay, so my point is programming is different from maths. We do have to know a very little bit of maths though. So now I'm going to show you a video of the very little bit of maths that we need to do. But this is foundational stuff that can then be applied to and extended to all other maths. So let's just get back to the fundamentals. Okay, so I've got a little video I want to show you. On YouTube.
I don't know where to start with this. So I'm going to go to Grammarly's new AI.
Ready to learn how to use these operators to make Python do math for you? By the end of this video, you'll know how to add, subtract, multiply, and divide in Python, along with a few more operations. We'll start off simple with the plus, minus, star, and slash operators. In Python, these operators let us add, subtract, multiply, and divide numbers, just like you learned in grade school. For example, to calculate the sum of 2 and 3, we first write the expression 2 plus sign 3 in a new cell. Then, to evaluate this expression, we need to execute the cell. To execute a cell in Google Colab, click the Run button on the left of the code cell. Or we can use a keyboard shortcut. To run a cell on Windows, press Ctrl plus Enter. On a Mac, press Command plus Return. Great! As you probably expected, 2 plus 3 is 5. Similarly, to calculate 2 minus 3, we use the subtraction operator. To calculate 2 times 3, we use the star operator. And to calculate 2 divided by 3, we use the slash operator. When we run these cells, Python does each calculation, and we get the results we expected. Awesome! Now that we know how to do basic math in Python, we'll explore a few more advanced operators. Let's start with the double star operator. In Python, this is the exponentiation operator. For example, to calculate 10 to the power of 3, we write 10 star star 3. Running the cell, we get that 10 to the power of 3 is 1000. Another useful operator is the double slash, or floor division operator. Unlike regular division, which returns a precise result including decimals, floor division returns only the whole number part. It calculates how many times the right-hand value fits evenly into the left-hand value. For example, to calculate the number of times 3 goes evenly into 13, we write 13 double slash 3. Running the cell, we get 4. This is because 3 goes into 13 4 times evenly, with a remainder of 1. If we want to directly calculate this remainder, we can use another operator, the percent sign or modulus operator. For example, we calculate the remainder of 13 divided by 3 by writing 13 percent sign 3. Running the cell, we get 1 as expected. Awesome! Now you know how to use the most important arithmetic operators in Python. We've created a notebook that you should check out if you want to get some experience working with what you've learned. We're working on lots more videos like this one, so be sure to subscribe so that you don't.
Okay, so that wasn't too frightening, was it? Right? Incidentally, I will copy this link in for you into the chat window so you can play around with that notebook if you feel like it. And I'll also just give you the link to this video itself so you can watch that again if needed. Okay. So a couple of things I want to say about X. So let me just fire up Google Colab. Oh, okay, it's getting here eventually. Now I'm going to say X equals 5. Okay, now I say X equals 5, but what I'm doing is I'm binding X to 5, as you know. So slightly different terminology to mathematics, but oftentimes I will just say X equals 5. Okay, so there's a bit of a language thing going on there, but we're in a programming context, so we understand kind of what we're talking about. Okay, so if I run that, what happens? Well, it just toodles away, and eventually they'll have a little tick next to it. Okay, so a tick means that it's run successfully, but nothing's happened. Okay, now the thing that you need to realize is that what has happened is that X is now bound to 5 in memory. Okay, so if I have any number of code cells in here, I might just throw in a text cell for fun. But then down here, I say print X. It prints 5. Okay? Because X is bound to 5 in memory. Okay. Now, what I want you to do is do exactly the same thing. So jump into Colab and type X equals 5. And then what I want you to type in, I'll add another couple of code cells. Just like I said, it doesn't need to look exactly like mine. And then I want to go print. Well, I'll print the type of X. What is X? What sort of an object is it? Now, those of you who've done the AI gym will know that X is an integer. So Samuel's question around, can you say it stores 5? The actual storage model, I'm not really going to talk about in a great deal of depth. Okay, so let's just stick with the language to say that binds to 5. Okay, so when I put the type in front of something, it's telling me that it's an integer. Now, one other little curiosity, I'll add another couple of code windows. Just the only reason I'm adding code windows is because I'm just showing you that it doesn't matter where this happens in the code. I could go back up to the start, add a code window at the start, and I could go print X and run it up there, and it will say 5. Okay, X is bound in memory. Okay, the point is that once I've run it, it's off in memory somewhere. Okay, somewhere out there. Is it on my computer? Is it out there in the universe? We shall see. Now, if I go print ID file, the ID of X, right? You'll notice it gives me this number. Okay. So what I'm going to do is I'm going to copy this number into the chat window. And I want all of you guys to run this particular line. So the 2 lines I really want you to run is, I'll just do the chat window. These 2 together. So run these 2. And then what I want you to do is I want you to copy whatever this number is into the chat window. And we'll talk a little bit about it. Okay, Samuel, has got the same number as me. Callum has. Dev has. Okay, you're starting to see a little pattern unfold. We've all got the same number. Now, what is that about? What's going on? Well, I'm going to talk to you a little bit now about what is actually happening when I say x binds to 5 in a very superficial level of detail. The number 5 lives on a Google server somewhere. Okay? If you say x equals 5, it actually creates a pointer in memory to that number. The reason why we're all getting the same number is because it's easier for Google to manage having a whole lot of things that point to the same number rather than having the number live somewhere else. So it does x equals 5, the 5 doesn't live on our machine is the point I'm making. It lives on a Google server. Okay? Now, if everybody picks a random number on the other hand, so I'm going to go x equals blah-de-blah, all right? Control Enter, and if I run this again, the ID, like if you guys pick a random number and do this, you'll note very quickly that this number is different, okay? Because what Google is having to do is it's having to allocate memory with this specific number in it. Okay, because 5 is a very common number, it uses the same little bit of memory to refer to the same thing, is the point that I'm making. Okay, it's more efficient to do that. If you pick some random number out of the blue and then ask it where it lives in memory by using ID, it will tell you its location, but it'll be different every time. Okay. That's really the point that I'm making. Okay, enough about that. So I just wanted to give you a little bit of an idea what we're actually talking about under the bonnet when we say x binds to 5. Okay, something's going on in memory. There's data moving around. It lives on a Google server somewhere. If it's a common number, it'll live in a specific area of memory called the cache. Otherwise, it lives somewhere else in memory. Okay. All right. So Nikki, you're saying you have a bit of a problem. Are you saying the problem is with this particular screen? Because I can zoom that up a bit. Is that better? Is that better? Yes, no? Oh, okay, cool. Okay, yeah, please let me know. All right. Okay. So moving right on. So we've dealt with arithmetic operators. Just get rid of that for now. Okay. So we've looked at this particular line. So I could have typed in x equals x plus 1. If I printed it out again, it would have given me 6. All right. Pretty straightforward. Okay. Now, another point to make that we'll be covering in future lectures. This is a command that you're giving to a microprocessor, and microprocessors try to be fast, okay? So what that means is that if the microprocessor doesn't have to read all of the command, it won't, okay? So if you create various statements and it can shortcut having to read the whole thing, like it reads from left to right, just like English, like a whole lot of other languages. It reads this as x binds to whatever's on the right, evaluates what on the right, then I'm binding that back to x. Okay? Okay, so just to come back quickly again to this screen. So we looked at this last week. So identifiers and literals. So x is a variable. It's bound to something in memory. We identify it. It's an identifier. Okay. I've got a bunch of things in there. It's a very large percentage of the code. Okay. We looked at the equal sign and the plus sign. Okay. They're both operators. Okay. So we've used a fair bit of that machinery just in that one single line of code. Two. So, like I said, 43 tokens. We don't actually have that much. We've started to get a bit of a grip on what's actually going on with it. And very shortly, you're going to be playing with these sorts of things in lots of details. Next week, we're going to be playing with the if keyword, which is a command. Okay. We've already played a little bit and we're starting to play with input and print. Yeah, so these very common things turn up in a very high percentage of code is the point that I was making last week. Okay. Now, there are quite a few keywords. So let me just jump back to here. So keywords are down here. We're going to be learning a bunch of keywords. So how do I find out what the keywords are? Okay, so let me copy something into the chat window, which will let you do that. Okay, so copy this into the chat window. So let me explain how to do that first of all. So go to Google Colab. Just pop it up there. Okay, so this is how I find out what the keywords are. So a couple of other things I should say about Google Colab. The reason I've got a number here, if you go to Tools, Settings, Editor, show line numbers. You can turn that on and off. So if you ever want to show me a bit of code and you want to talk about particular lines, you can have it there. But if I turn that off, then that'll do that. I also find the AI annoying in Google Colab. So I will turn off the AI assistance. Okay, it still has that down the bottom, so I'll switch that off entirely, and it gives you more window as well. Okay, but I'm going to turn back on the line numbers just so we can talk about our things. Okay, so Control-Shift-V copies from there. We've got 3 lines of code here with some comments around it. So note how this is different colors. Control-Shift-V lets you copy things in directly. So maybe that would have worked before when I was copying things directly from Word, but I forget about Control-Shift-V. Anyway, so what do these 3 lines of code do? Okay, they give you the list of keywords. Just let me make it big again. Okay, it gives you a list. And it also gives you a true. Now, this true is for this last thing here. So if I want to get rid of that, I can do Control \, comment it out, and it will just give me the list. So this is all of the keywords. There's 35 keywords. We're not going to be doing all of them this semester. We'll be doing 30 or 31. I can't remember. But when I say keywords, that's everything in here. So you'll notice that there's, if this, use this line if you want to check if a particular keyword is in there. But if I scooch across here, you'll see that, else, elif is down in here and so on. Okay. So this is a way of finding out what all the keywords are. And that's 8% of code, typically. Okay. So okay, so given these functions are pretty central, the input and print functions, I'm now going to give you a quick video to show you, again, how these work. Okay, so here we go. Let me switch off the ads and link on. So you spend a lot of time using print. Okay, you want to find out what's happening. You need to use print to actually get under the bonnet. Hopefully this will.
Want to make your Python programs more interactive? Asking users for input is the key. After watching this video, you'll know exactly how to ask for input while avoiding a common beginner mistake. To get familiar with the syntax, we'll write the code for this simple program that asks for a user's name and outputs a customized greeting message. In Python, the easiest way to get user input is to call the input function. To understand what the input function does, let's run the cell. As you can see, the function call created an input box under the cell. At this point, the program is waiting for the user to enter information in the box. This is fine, but without more context, it's hard for a user to know what to input. To prompt the user for a specific input, we can provide a message as an argument to the function. Since we want the user to enter their name, let's pass the string, "Enter your name." Now when we run the cell, our prompt is displayed before the input box. Much clearer. Once the user inputs their name and presses enter, the input is displayed in the output box. That's fine, but remember, our program should greet the user by printing hello followed by their name. To create our greeting message, we'll first save the return value of the input function to a variable called name. Then, we'll write a print statement that outputs hello followed by name. Now when we run the cell, the user is prompted to enter their name, and the custom greeting is printed. Great! In this program, we ask the user to input text, but we can also use the input function to ask for numbers. However, when asking for numeric input, beginners often make a common mistake. Let's see what that mistake is and how to avoid it with another example. This new program will ask the users for two numbers and add them up. For example, to add 1 and 2, we run the cell and enter 1 and 2 as inputs, and get 12? That's not what we expected. Why did this happen? We got 12 because the input function always returns the user's input as a string. So, the plus operator concatenated the two variables instead of adding them. We can confirm that these variables are strings by using the type function. Number 1 is a string. Luckily, numbers represented as strings can always be converted to integers or floats. To avoid working with data of the wrong type, it's good programming practice to immediately cast user inputs to the data type we expect. For that reason, we'll cast the user's input to floats using the float operator. Now we can safely assume that both of our number variables are floats. When we rerun our code and enter 1 and 2 again, we get 3. Great! Now you know how to collect user input and ensure it's the right data type. This program will work great as long as the user enters numbers. But users don't always follow directions. This can lead to errors that crash your program. To keep your code running smoothly when using the input function, check out our video on error handling in Python. We left a link in the description.
Okay. All right, let me give you the link to that in chat. That's a good reference for you. Send it to the right person. Okay, all right, let's get into this week's lab. Proper. I'll just spend a little bit of time in that, and we can have a look at that quickly. Look, before we do, maybe I'll just run a little test with us. I'm going to fire this up. So you're going to need a mobile phone to do this. This is a Mentimeter test. I know you did the AL labs and you've been looking at some stuff and going ahead. So yeah, just jump on the phone, pop the QR code in, and let's get some responses to this and see how we go. So you're not going to be identified. If you get it wrong, doesn't matter. I just want to, I just think it's really important as a mechanism of learning here to make a prediction, right? Before you do anything. Thinking is involved. If you make a prediction, you're kind of committed. If you're right or if you're wrong, you actually remember it better than if you're just sitting back, letting it wash over you and in one ear out the other, which is something I'm very good at. Okay, we've got 8 out of 17 in there. Let's get a few more. Okay, print age plus 20. What do you reckon? Okay, 14 flowing in. Okay. 15, 16. Okay, moving right along. Print age plus 20. Does it print the first line? Is it the second line or is it the third line? Let's find out. Okay, show responses. Okay, a bit of a mix. Okay, let's see. So what do we think here? This one is the dominant one. But you know, these two outweigh this one. Show correct answer. Okay. Crashes with an error. So yeah, interesting. Why is it the case? Let's prove it. And what sort of error is it?
It's a type error.
Type error? What do you say that?
Well, I ran the code.
Oh, you ran it. Good one. Okay, so let me do it. Okay, so print age. What is going on? Am I in the box? Print age plus 20. Okay, so how informative is this error? Okay, there's only one error. There's just a single line, obviously, so the error is obviously in that line. Can only concatenate string, not into string. Okay, so what on earth does that mean in English? Okay, remember how I said you can add numbers together, right? Obviously, 2 plus 3 equals 5, you can do that. And if you use it in the instance of strings, you can say 1 plus 2 equals 12. Yeah? But you can't cross the streams, okay? You can't add these things together. So if I went like this, sorry, I won't remember to put that in there. That works, okay? Because I've added 2 strings together. That's okay. Yeah? But you can't mix and match. Okay. 2 mobile phones. Let's do our next one. Okay. X equals input, enter a number, print X plus 1. Okay. Say I type in 5 and then I hit enter. What is going to print out? Let's see how you go. Okay. There seems to be a lot of belief in this one, that you're actually going to get 6. Now, what if you typed in a letter? What would happen? Is somebody actually typing this into Google Colab? What happens if you type in a letter? Well, going back to the previous question, we know that x plus 1 doesn't work if you've got different types together. They need to be both integers or both strings. You can't have an int mixed with a string. Okay, so it would crash on that line. Okay, so show the correct answer. Okay, let's try it. Okay. X equals input, enter a number, print x plus 1, run that. Hitting 5. Again, it's a type error. And again, it's the same thing, right? So the key is this. If I get rid of this line and I go print type, print the type of x, and I hit 5, it's a string, okay? Now, I said this last week, I think, but Python's really fussy about what you type in, okay? It treats everything you type in as a string, okay? Just because I've typed in a number, there's a few people taking this into account in the chat window, okay? The way to turn it into a number is to stick this function int on the front. So now if I run it, it's an integer. Okay, so when I print x plus 1, I'll get rid of that line. It'll now work. Okay, you need to know this for the homework. Because if you just use input, you're always getting a string, is the take-home message. Okay. So again, with this one, everybody assumed that x would be an integer, and it's not. It's a string by default with input. That's the take-home message. Okay. All right. So this one person will be feeling pretty good about themselves because they were the only one to get it right. But yeah, what I'm really trying to do is focus in on very common misconceptions and unwind them before we go too far. Okay, next slide. I type 5, then hit enter. What prints out? Okay, x equals input. It's very similar to the previous question. Jump on the QR code and have a crack. Those of you who aren't. Okay, let's jump over here and find this out. Okay, so this time instead of doing the int up here, let's get rid of that one entirely. I put it down here. So I'm making this an integer, and this is already an integer. Okay, so I don't need to do it up there. I don't have to do it up there is the point. So x starts off being a string. I might just show you that by leaving the type in there. X starts off being a string, but then this turns it into an integer, so I can add 1 to it. Now, if I didn't do this, that would crash. But if I turned 1 into a string, that would be 51, right? Because plus then figures out, oh, I'm concatenating, I'm sticking 2 strings together. Okay, most of you were all over that one. Okay, couple to go. Okay, so it was 6. Most of you got that one. Okay, so what happens with this one? So now we're using int on what's called a floating point number. Now, I remember in an exam once I asked a question, what's the difference between a floating point number and an integer? And somebody gave me the answer. Integers are solid and floating point numbers are a little bit squishy, which I thought was pretty cute, but you need to be a little bit more precise than that in an exam situation. So a floating point number, 3.9, it looks like a decimal, but it's just any number which has a number of places. Okay, so it's not a whole number. Okay, so what have we got here? Print int 3.9. Let's see what we got. One person said it gets to 4. A lot of people said it gets to 3. Okay, so let me add a new code window. So we've got a couple on the crash. Okay, so print int 3.9. Okay. So int chops off anything following the number. Now, something to remember. If I make that negative 3.9, does it become negative 3 or does it become negative 4? Is it getting closer to 0 or is it just chopping it off? Well, as I told you, it's chopping things off. Okay? So it's chopping off the last bit. All right? Remember that. That's a very common exam question. Okay. So how do we go with our answers? In 3.9, most of you picked 3. Good job, team. All righty, next one. Okay, so this is the last one. I hit 3.5, then hit enter. What happens? Okay, am I storing? I'm typing in 3.5. I'm storing 3.5 as an integer object, storing 3 as an integer object, or it's crashing. What do you reckon? Make a prediction. Okay, 3.5. Okay, so invalid literal for int with base 10 3.5. So what's going on there? Okay, I'm going to leave you to explore that one. Okay, I'm not giving you everything. I'll copy that into the chat window, but have a look at this for homework and figure out what's going on there. Okay. All right. So much for that. Okay, let's get into the homework for this week. So we've covered everything that you need for lab 2, but let's just quickly whiz through the homework for this week. When it fires up. The time, I can't see the time. It's getting on. Time is ticking. Yeah, we've got enough time for that. Great. Okay, so fire up your homework. So module 2. And yeah, I'm going to stop recording now.